So this is in general what you do. Okay, so get your calculators out and calculate along with me. Okay, so the first thing I'm going to do is if I've got this thing, is I'm going to look in here and I'm going to try to find where I can start. And let me just show you where I'm not going to start. Right? Certainly, I can't say that the 4 and the 10 are in parallel, can I? The 4 and the 10 are definitely not in parallel. That's because there's another 6 right here. Isn't that right? Okay. I can't say that the 4 and the 6 are in series either. Right? And that's because there's like a branch there. And series circuits don't have branches like that in them, do they? No. Okay. So series circuits look like this. They just look like, right? There's no branches coming off. There's just, that's what it is, right? If they are hooked like that, right, then they are series. All right, and then parallel circuits look like they look like something like this, and then the ends are somehow, and we can twist the way we draw these things, but ultimately these guys are in parallel if both ends on this side are connected and both ends on that side are connected, right? So the only place to start in this circuit is right here. These guys are in series. Yeah? All right. There's stuff for you in the handbag thing if you want to. This thing right here. Okay, so 4 and a 6 is that's a 10. That's easy, right? Okay, so I just added that as if it were series, and it is, right? Okay, and then this one's actually one where we don't even need a calculator. Okay, so then the 10 and the 10 is well, 10 and a 10 in parallel, right, is 1 over 10 plus 1 over 10. Well, that's 1 over 2/10, which is 5, right? Yeah? Okay, so that's 5 ohms, right? And then we've got these guys here, and if you look, it's this one. Now that's one resistor. It's a 5 ohm resistor. We're seeing that in our head, right? This is a key concept. We got to be able to picture everything that's circled there as just one resistor. So it's a 4, a 5, and a 6, which adds up to 15, isn't it? Yeah? Right? So that is series. It's this one, then it goes into that one, then it goes out of that one. Your ends are connected together like this. Yeah? Even though it goes in a circle or in a curved path like that, that's the way it is. So this one's just simply 4 plus 5 plus 6 is 15. And now we've got, how are the 15 and the 15 connected? Are they series or parallel? Parallel. Those are parallel because this end is connected to that end, this end's connected to this end, right? It's connected like this, right? Okay? So these guys are parallel. 2 15s in parallel is well, it's a 1 over 15 plus 1 over 15, right? That's a 7.5, yeah. So the total resistance is 7.5 ohms, yeah? Wow. All right. So get out, you've got your little circuit exercises there. Let's go look at the first one. See if you can figure out the first one. Let's escape from this and go. Okay, why does that look like that? I don't know. There you go. So the first thing I want to do is you guys take your calculators and calculate what the resistance is that the battery sees. Okay? Calculate what the resistance is that the battery sees. Yeah? So this one you only have to circle one thing. This is pretty easy, isn't it? And just write the resistance down, and I'll do it up here, you do it there. Okay? And that's our first step, is that we're going to take the circuits and we're going to break them down and make one resistor out of them. So this one is 5, 12, and 24. And 7, right? So this one's easy, right? We just circle this. What's the resistance? How are those connected? Those are parallel, right? and a 12 and a 24 in parallel. It's 1 over 12 plus 1 over 24. Oh, yeah, that's our other formula, right, that we use. So it's not just these guys, right? It's also that for series circuits, R is R1 plus R2 plus R3. And for parallel circuits, R is equal to 1 over R1 plus 1 over R2. And then, of course, you can dot those, right? Okay, so 1 divided by 12 plus 1 divided by 24. Is that just 8? So that's 8 ohms. And now what's the total resistance? Well, 5 and 7, how are these guys connected? The 5, the 8, and the 7? Those are series. We don't joke about those, right? Right? And 5 and 8 and 7 add up to? Is it 20? Does that add up to 20 even? Yeah, there you go. Yeah. Okay. So let's turn the page. Everybody get that? That's the basic idea. So let's turn the page. Let's look at the next one. And you'll see why we call him a single popper. So I'm just going to find the resistance I've got. I'm going to ignore the meters right for now. Right? And then I'm going to go. So this is 11 ohms. This is 8 ohms, 7 ohms, 5 ohms. This one's not going to come out evenly. So let me show you an important trick. And that is that we need to store values in our calculator as we go. Okay, so 7 plus, where do we start? 7 plus 8, yeah, there we go, right? This guy, we're going to start with this guy. 7 plus 8 is 15, no tricks there, right? And then how is the 15 and the 11 connected? How are they connected? Those are parallel, and then we're pretty much done, right? Okay. And so this is 15 and 11, so that's going to be 1 over 11 plus 1 over 15, right? So I go 1 divided by 11 plus 1 divided by 15. With the TI-83, the key structure, so this is 6.346 ohms. And I'm going to store that in A. So this is what I do. Is I just do this. I go A, and then I say that it's that. Yeah? Right? And now when I want to figure out the total resistance, when I want to find the total resistance is just simply, how is the 5, the 6.346, and the 9, how are they connected? Yeah, those are series. They're just connected end to end like that, right? So now I can just go 5 plus A plus 9, right? So 5 plus alpha A plus 9, and I get 20.346. Yeah? That's not so bad, is it? Okay. Should we do something a little more difficult?
Do it.
Should we do number 3? Sweet mother of... And now notice that the resistors look highly rectangular. This is the way they'll look on the IB test, because apparently in Europe that's how they write resistors, which is definitely communist and wrong. I'm just kidding. I'm just joking.